Okay, so here's an example of using slope-intercept form. Here we're going to use slope-intercept form to graph. My graph looks a little funky, it's missing some lines, but yours should be fine. So in slope-intercept form, y equals mx plus b. We always have a y, we always have an x, and m is slope, whatever that number may be, and b is always your y-intercept. So whatever number is in for m, that's going to tell me where to move. But b, most importantly, is the y-intercept, which tells me where I'm going to start my graph. So in this case, the constant, or b, is 7. So we're going to put a point at 7, intersecting the y-axis, which we know what y-intercepts are from our key features of a graph lesson. Now we're looking to use a slope of 2/5. Now the problem is 2/5 rise over run. We rise and then we run, right? You rise out of bed before you start running. And we have to move up 2 and to the right 5. I don't really have room to move up 2 units. I can only go down 2 units. But if I go down, then I have to go to the left, because down is negative, left is negative, and negative over negative makes a positive. So down 2 to the left 1, 2, 3, 4, about here. And normally you could go up and to the right, which is both positive, but I ran out of room on my graph. Find the way it is. Okay, you know where that line's supposed to go, so we'll just leave it right there. All right, number 8, my y-intercept is 2. So I'm going to put a point at 2, and my slope m is -1. So I could move down and to the right, because this is a negative move and that's positive. Negative divided by a positive is still negative, or you could move up and to the left. You made 2 negative moves, negative over negative is a positive, and that's no longer a negative slope. So I'm going to do both. I'm going to go down and to the right and up and to the left. And if you notice, it makes the shape of a line. And then we'll keep going. And that's your line. Again, this line's probably not going to go where I want it to go. Oh, okay, there we go. Okay, so number 9, there's 2 ways to do this. Now, I'm going to use what we learned in the beginning of this lesson, which was to switch forms. So we learned to go to other forms in standard form. Standard form, again, doesn't really tell us much. We will learn in the next lesson how to use its x and y intercepts, but for now, we really aren't able to graph in standard form. It's best to change this slope-intercept form, because that's what we know how to graph. So I want to get y equals, and most likely it'll end up looking like y equals mx plus b. So let's subtract x on both sides, and I get 3y equals, and because this x term comes first in comparison to the constant, I'm going to make my x term come first in comparison to the constant. Now to get y by itself, we'll divide by 3. And if you think about the coefficient here being -1, that'd be -1/3 x minus 5. Okay, so my y-intercept is -5, and my slope could be up 1 and to the left 3, or down 1 and to the right 3. Either way, it's the same line. We always need arrows on either side of our line, because lines go on forever. It's not just the points that I decide to graph, it's points on that line into infinity. Okay, again, I'm going to leave this one for you to try on your own, and that'll be part of the grade for the packet. Okay, horizontal and vertical lines are pretty simple. There's not really much to know about them. You want to write an equation to represent the line. All vertical lines are always x equals, and horizontal lines are y equals. And a lot of times we get those mixed up, but the way that I think about it is that this crosses the x-axis and this crosses the y-axis. And that's how I know where to put the line. X equals a solid whole constant number is going to be a vertical line, and y equals a whole number is a horizontal line. So it's whatever x value that you're hitting. So x equals -3. And to you, that might look like just a value, just a point, or just x. But if you think about it, every point on this line, x is -3. Okay? And there's an undefined slope because this is not in slope-intercept form. It is a vertical line. Vertical lines all have slopes of undefined. In horizontal, this is going to be y equals 1 because every point on this line has a y value of 1. Slopes of parallel lines are the same, while slopes of perpendicular lines are opposite, reciprocal. Determine whether the pair of lines are parallel, perpendicular, or neither. So the only thing that I know about parallel and perpendicular lines are slopes. So the only way that I'm going to know if something's parallel or perpendicular to another line is if I know its slope. So all you really have to do is identify the slope here and identify the slope here. Remember that we always use m to identify a slope. So to know the slope, I'm going to want to have the line in slope-intercept form. So let's change number 13 into slope-intercept form by isolating y. So I get 5y, -10x plus 5, divided by 5.